Good morning to all of you, sir. Welcome to the third day of our 21 days training hands-on of RS and GIS using QGIS. My voice is clear, sir?
Yes, sir.
Thank you.
हाँ, आज वॉइस क्लियर है। कल बहुत ज़्यादा ब्रेकिंग हो रही थी।
Okay, sir. So today we are going to discuss about different geoportals, and so we're going to discuss about the introduction to GIS. So should we wait, sir, or 5 more minutes to add more participants in this training? Maybe there are 30 around. So, or should we start? Maybe we can wait for 5 more minutes. If someone.
Okay, we can wait.
Yes, sir. So we are starting the session now. So we are going to discuss about the different geoportals that are available. So first geoportal is basically the Google Earth. Google Earth is quite familiar. I think many of you already use this. But this is the you can say it's a free access to the high resolution imaginary satellite and aerials. So basically in Google Earth you can see there are the whole world picture. You can say high resolution images are there, and it is not reflecting the real time pictures, but still you can visualize the things or you can identify the areas, geographical areas through remote Google Earth as well. So we are first going to see what exactly there in Google Earth. So I have given the access path here. So I'm just taking you to this website, Google through web. Is it visible, sir?
Yes, sir.
Okay, sir. Thank you. So you can see this is basically the Google Earth web, and this application you can basically you can search for any place if you want to visualize. Suppose you want to visualize Jabalpur, you just have to search Jabalpur here, or you can say you have to visualize a JNKVV. So you can see the images of, these are the high resolution images of our campus. So these are the facilities in this. There are a number of things. I think I have to open Google Pro. Some features are not available in web version. I think. You just give me 2 minutes. You can download also the Google Earth Pro. You can download from the web. It's freely available. So you can see here. I have already downloaded from the web this version. So it is similar to the web version, but there are some more features that I want to show you. So we are going to see our campus, right? JNKVV Jabalpur. So this is our campus. We are going to our campus here. Okay. So what I want to see you that you can visualize the thing here. Okay. You can even overlay some images over here, whatever the pictures belonging to that particular place you can do here. You can also do some path mapping here. You can add some benchmarks, like if you identify some places here, suppose this is a ground. So you can just add some path marks here. Like this is, you can just move this to here, and you can mention those places. Okay. So this place marks you can do from here. You can also do some polygon. You can also add some polygons here. Polygon, the adding of polygon is meaning to measure some areas, whatever the area are. So if I say this is JNKVV, and I just okay, save it. So here this place is saved as JNKV. Now I can add a path, a polygon. So let's say I'm adding a polygon here. Okay. So yeah. So this cursor basically, if you hit this polygon feature, you can find this cursor here. So you just have to press this button and you can just mark it out. Any area you can measure from this surface. Suppose you have to measure this particular area, you just create here, okay, and your polygon has been created. Okay, so you can do measurements also, just like it's showing 3 miles here. So likewise, there are areas you can measure here. You can add some paths also. If you have to add some path, you can just click here, and this vertical line, you can even measure the entire campus through this path. If you just hit this button, you can able to see, and you just add these points here. Okay, so on the basis of that, this area has been basically, and this you can see here that it's measured that 0.89 miles is this particular area. So this type of things you can do here. Okay, and if we have created this polygon, you can save these polygons to the different files, like that is KMZ files and KML files. I can show you, like suppose this is the polygon. Okay, and I have mentioned this as a JNKVV. Okay, and you can save this place. You can save as a KMZ or KML file. So KMZ and KML file is basically used while you are doing the image processing to convert it to shape files. So if you don't have any shape files, you can do with the help of Google Earth also. You can just create a polygon. I am just created a random image, but you can do some little bit finer. You can do some finer resolutions, and you can just save that polygon. So that is your outline boundary. So on the basis of that, you can use that shape particularly as a shape file. Later, there is a functionality to convert these KML and KMZ files. There are two things, KML and KMZ. So these files are converted into the shape files, which will be, I think, the uses of that shape file will be discussed in the later sessions. So these are the things I want to show. Anything you can visualize. So this is about the Google Earth. I'm just closing the session. Yeah, Google Earth. So similarly, Google has also offers another feature, that is a Google time lapse. So Google time lapse is something that is basically showing you the temporal variations over a period of time. Suppose you can see here that this is a Colombian glacier. Okay, So you can find out the temporal changes over a period of time for a particular specific area. So this kind of things you can do here. So you can see in a time bar downside of this screen that years are moving from 1984 to 2020. What are the changes that have happened over a particular area? So these are the features that has been a new feature, and it's now they are improving this feature for the different places. Like this is a mining, so you can observe the temporal variations of different sites. So you can see here like how the mining affects the complete area. So that kind of change detection, or you can say land use land cover changes over a period of time can be identified from such analysis. So this is Google Labs. There are many features out there. You can see like construction, drying of a RLC, urban growths. So you can observe the urban growth as well, like how the urban growth is getting increased over the year. You can see here, it's showing the complete world. If you just zoom out, you can see that whatever the changes happening over the world, you can visualize the things. So this is very nice feature from the Google Earth Engine, basically time lapse. So just want to show you. Now I'm just closing this window. So what are the uses? So it's very, Google Earth is free to use for non-commercial applications. It has a very large library, okay, and there are no account has needed to browse data. So this is pros, and cons means recent images might not be downloaded because real-time images Google didn't show. It just show 1 year, 2 year back images. So and there are some license provisions for the commercial applications. So these are some cons here. So this is first Google Earth. Similarly, Zoom.earth is the another Google you can say geoportal where the near real-time features are available. These are similar to Google Earth because there is a competitor Binge. You might heard it. So that Binge has developed this Zoom.earth. So let's see what exactly differs in the Zoom.earth. So it is also free of use. It has also large libraries there, but it has some different features that I just want to show you. So in this Zoom.earth, this is India's map, okay, and you can see there are some scales are there. So these scales is basically for the measurement, distance measurement like Google Earth. You can measure those distances from this point to this point, this point to this point. So distance you can measure it, okay. So just a minute. Okay, so I just have to remove this. I think we have to cut it down. Okay, leave it. So I just want to show you how to measure the distances here. Should be some provision to, yes, okay. So this is for the measurement, and now in the downside you can see that you can see the wind animations. So in July 31, the time is showing here 10:15, and you can see, you can visualize the wind that is moving around the India from southwest. Winds are there, so you can observe. So this is basically available for the whole world, this feature. So similarly, the rain data, rain features are also there. You can observe the wildfires and source of heats are there. So there are a number of features, different features from the Google Earth that has been given by the Zoom.earth. So you can monitor the things real time. So I'm just closing it. So now moving to the Earth on AWS. So it basically provides the free satellite data, and it is the widest repository, you can say, for the satellite data, because all the different platforms, it may be Sentinel, it may be a Landsat, it may be anything. So basically they are using the Amazon Web Services. But here you can say that there are a number of things: Sentinel-2, Landsat, GIS, NOA, Sentinel-1 data. So basically, these data are basically reposited by the different agencies to Amazon Web Services, and they are now being provided by Amazon itself. So, but the cons here that the data is not browsable. You have to know exactly what you are looking for. So this data may be requested to an API. That is the application interface needed for this particular data type. So the people who are looking to automate the processing, suppose you want something that moves dynamically, you don't have to be downloaded. You have just given the path, what image you are exactly looking for. So you have coded those path in your program. Let's say you can say that you want to be a real-time weather forecasting. Okay, and on the basis of that, you have coded your program. Like if we get the image on 15 minutes or 30 minutes, and on the basis of that, we can cut down the image for a particular area, or a particular area, and we can just alert if there is any problem, or if there is a heavy rain or a cloudburst. We have to alert some people and around us. So for those, the process is completely automated, right? So we can just send if there is a disaster happening, we can send the SMS to all the people, or we can say all the administration purpose people, to inform the people. So this kind of thing for automation, you can say the Earth on AWS is available. Data is available free, but you have to build access to an API. Now comes to NASA World View. This is a browsable open platform. This is also providing the large variety of data. So it is providing daily data, global true color, surface reflectance imagery at 255-meter resolutions. So Moody's images there from the Terra satellites, Moody's satellites image you can get from this worldview. So this is also free of use. It's non-commercial applications. Large library is there and easily browsable. If you just have a look here for NASA worldview. So this is information that has been there. So just close it down. You can get the different parts. Even you can search the places here. You can search Madhya Pradesh. Currently the data is not showing here, but if you just zoom, it's available to this particular area. So in this particular area, you can visualize the thing over here, and even there is a provision to cut it down, and you can download also. And you can also set up animations also. From suppose you want to animation from you have to monitor the changes from different duration, like 2020 to 2021, and you set an animation. So it will show you that what are the changes that is happening over the period of time. Just taking some time because this is a very huge imaginary. It took a lot of time, so I'm not just cancelling it because it will very large time. So this is about the world view. So cons is because basically provide the low resolution data. This is ideal for specific event observation from space, such as wildfire or storms. So this is world view. Now comes to the NOAA. NOAA is a National Oceanic and Atmospheric Administration group, which provides satellite images. So they have their web portal, and they freely offer images to satellites like GEOS and NOAA-20. So this data is approximately in every 15 minutes, the data is available. And this makes you can say it's a real-time satellite data. You can say it's just 15 minutes data they are sending. But GOSAR is basically the geostationary satellite. So they are locating in very high orbits, nearly 36,000 kilometers. So this means the data they have produced are very low resolution, 250 meters or more. So basically they are used for weather events. So here I mentioned pros, like real-time satellite data is available, but having a lower resolution. That is the cons. And this is suitable for weather monitoring. Now this is the land viewer. You can see this is a very good site for image analysis also, as well as image download. There are a number of data that has been available here, like Sentinel-2 Sentinel Landsat is also available in this site. And there are some limitations in this basically land viewer. You may be able to download only one or I think nearly 10 images you can download. After that, you have to pay for certain charges. So this is land viewer. You can see next. Okay. So you can see here this image has been marked. Just a minute. You can search a different scene. So I'm just searching for Jabalpur. Okay. So now it's showing this Jabalpur image. Okay. And even you can draw some rectangles kind of. You have to search a lower image. You can find out this area. Okay. And based on your study area, you can just select this rectangle. There's a rectangle area is there. On the basis of that, you can just demarcate your boundaries for the particular area. So this is basically we have created the portion is basically area of interest or AY. My AY is AY is just area of interest where you are going to take the studies. So there are things I want to show you. Settings. AY is there. Yeah. So here some facilities are available for time series analysis also. You can see here. And this land viewer, you can see that if the satellite is there and you want to do some analysis on NDVI or NDWI, so you can do. NDVI is basically the normalized difference vegetation index. for basically used in the differentiation of special crops, you can say agriculture crops or vegetations. Okay, so you can see like NDVI, the sensors are there, and period you can mention from 1 month, 3 months, 6 months, 1 year, 3 year, 5 year, 10 year. So you can apply this. Okay, so on the basis of that, it will just basically study the different reflectance over the period of time, and it will just plot it. But this is basically very limited. You can say you can just gather 10 scenes per day. So every day they are offering for the 10. So you get this graph. So you can plot the different indices through this land viewer. So this is all about the land viewer here. Now we are moving to this India VARIS. India VARIS means the Indian Water Resource Information System. This is basically developed by the government of India to integrate all the rainfall, or you can say the water resource data in a one platform. So here you can see that in this Indian map, you can just a minute. I'm just showing you. So this is the India VARIS platform here. Okay. So in this map, you can see any select any state like Madhya Pradesh. Okay, and on the basis of that, you can get these data like rainfalls, reservoirs. So you can get what are the normal rainfalls, what is the actual rainfall, or what is the deviation from the normal till from 1st of July to 29th of July. So basically, this type of calculations, this is very good platform basically because many data are available in this India VARIS site. So here we can see more data also. Just zooming out. Okay. So similarly, you can also see any state. These are the basically you can see that you can just click any state and you get the information about rainfall, reservoir, river points, evapotranspiration, soil moisture, water quality, and minor irrigation tasks also. So this is very informative platform from the government of India. Even you can download this data. So this is about the India VARIS. Now moving ahead to Sentinel Hub. Sentinel Hub is basically you can browse the Sentinel data here. So Sentinel Hub is you can say there are a number of it's not only containing the Sentinel data, but even containing the Landsat as well as Moody's product also. So there are a number of data set carriers are currently available with the 5 days revisit dates. 5-day revisit means there is a repeativity of satellite in 5 days for a particular area. Okay, so the images. Hello. Hello, my voice is clear. Hello.
Yes, sir.
Okay. So you can get the number of products in the Sentinel Hub. Cons is the resolution is not sharp enough for many applications, such as counting of cars or construction monitoring, tracking of aeroplanes. So these are some limits. But we can say in our natural resource management or in agriculture applications, these are very good use of Sentinel images, and they are currently widely using. We are in almost most of the researchers we are using the Sentinel images. So I'm just browsing the this hub Sentinel Hub website. So this is also kind of similar thing. You can see. You just have to find out any place, let's say Delhi. Delhi, India. So this is the image. If you have to cut image, just you have to select some tool here. Maybe there. Just do that. Yeah. So you can just select just so this is a random area I have taken. Okay, and you can search the different products that are available in this EO Sentinel 1, Sentinel 2, Sentinel 3, Sentinel 5P. So I'm just selected the Sentinel 2 here, and you can search it. So you can see that these are the images that are searched basically from this belonging to this particular area. Okay, so you can see that this is the satellite image that is basically captured. So you can do search the different images which are which can measure your particular area. Okay, if your area is covered under that particular satellite image, so you can able to download those images. And how you can download those images, there is a link provided here. Okay, so you can just click this link. Okay, so this is a AWS path. You can access those images from directly from AWS through this path. Okay, and if you want to download it, you can just click this link and you can download those images in your PC as well. So this is how you can download from the Sentinel images. So this is Sentinel 1 that has been launched in 2014. Okay, this is basically the radar satellites. Sentinel 2 is basically the most common that has been used by Sentinel Hub, that are more than 13 bands. So multispectral images are there in Sentinel 2. Okay, 10 meter, 20 meter, 60 meter resolutions are there, that depending on the locations. Some places there are 10 meters, some places there are 20 meters. Similarly, the Sentinel 5P satellites basically that provides the atmospheric monitoring data. So they are available in a form of like NO2, O3, CH4, cloud. So these data you can take from Sentinel 5 in it. You can say on a grid basis up to 5.5 kilometer to 3.5 kilometer per pixel grid. Okay. Similarly, in a Landsat, that is another most widely used images. That was most widely because they have a large, you can say, large repository. Start from the 1972. So data is available from 1972. So start from Landsat 1 and now Landsat 9 to be launched in this year. Okay, so this data has become free by USGS in 2008, and they have 11 bands. Okay, and this is similar to Sentinel-2. Images are almost similar to the Sentinel-2, having a spatial resolution of 30 meters. So Sentinel-2 offers 10 meter resolutions. Depends on the specific locations, resolution may vary. Okay, so these are the 12 spectral bands and coastal areas to shortwave infrared band. So this is about Sentinel data. Now comes to the Copernicus Hub. this hub is basically also accessing the Sentinel data only. So you can get the Sentinel images from this platform also, that Copernicus Open Access, that is being managed by European Space Agency. So you can directly download the images through API, including the SAR datasets. SAR datasets is basically, you can say, scientific aperture datasets that is being captured by radar, and it can have images of day and night also. So this is, and cons are restricted for the commercial applications. It can be used for the research purpose, but commercial you have to take the licenses. So I'm just giving you an overview of this Copernicus Open Access. So it is just quite similar to almost all the, you can say, data providers. I'm just typing here. Sometime not recognized. Jabalpur. So it's basically asking for the user name and passwords. And many times when you have to download the data, you can browse the data, but if you have to download the data, you have to be login to that particular platform. So I'm just logging here. What is the password? I forgot my password. So I'm just let you show you that how you can just select this square box, okay, and once you select this square box, and you can just draw a polygon over a particular your area of interest, okay, and you can just search it, you will get your data. So this is about the Copernicus Open Access Hub, okay. This is a ESA, basically it's a platform of European Space Agency. And they are also providing the same Sentinel-1 and Sentinel-2 data. So now comes to the Bhuvan. Bhuvan is the Indian web-based utility which allows user to explore a set of map-based content by ISRO, Indian Space Research Organization. Okay. So these contents are limited to the Indian territory only. Okay, and there are 4 regional languages where you can see the, you can say, the databases like Hindi, English, Tamil, and Telugu. So the content, including the thematic maps related to the disasters, agriculture, water resource, land cover, and process satellite data from the ISRO. Okay, so we just see what exactly there in Google. So I have just clicked that link. So now we can see but these are the basically, this is the platform of Indian Space Research Organization, Bhuvan. Okay, so there are a number of things. You can see that the visualization and free download is there. So you can visualize the data, you can download the data here. Bhuvan 2D means there is basically the 2-dimensional data is there. 2-dimensional means latitude and longitude is there in this data. In Bhuvan 3D is basically the 3-dimension data. 3-dimension means there is a altitude is also available. Okay, latitude, longitude, and altitude. So Z direction is also added in Bhuvan 3D. So this is the open data archive where you can download the data. Okay, these are the climate and environment features that has been there, which is basically processed, or we can say that derived from the satellite data. So these are some visualization and free download features here. You can see there are some application sectors also. Application sectors are, we can say that's a government planning, or you can say it's an e-dashboard for the government, where number of government programs have been monitored, where the geospatial technology is being used. So there is agriculture, okay. So agriculture, there are base surveillance, and plantation is there. Okay, water, you can see that the number of things are there. So you just click here. There are forestry applications are also there. So just a minute. Old website is, I think, much more clear here. Okay, so this is the old website. Basically, they have just shifted recently to the new website. So these are we have already discussed 2D, 3D, open data archive, climate environment, basically, which is derived from the satellite images. Okay, so thematic services are basically, you can say, not a satellite images, but it is derived information from the satellites. Okay, disaster management support services for managing the disaster services. Here, there is facility to create a map. There is no need of any specialization. Anyone can create map and select their data. Okay. So these are some government and central ministry e-governance dashboard is there. So lot of information is there. Toll information. Recently, that government launched e-tag. Groundwater details, groundwater inventory, or spatial groundwater inventory, you can say. The pipeline grids, watershed information, urban surveys, coastal, bioenergy, GIS information, and monuments. So these are the different spatial features which has been maintained by the government central ministry, you can say. So these are there in this Bhuvan. So ISRO is managing, Bhuvan Portrait Form is managing this information about the hailstorm, PMKSY, Clean Ganga Mission. And then now comes to the agriculture sector. You can see there are some things like what are the application parts in agriculture. Let's say discuss. You can see what is there in agriculture. So you can see that the base surveillance information, RKY, and plantation is there. In forestry, if you click, you can see that the forestry information of different states are there. And this information is basically keep updating. So currently it's showing just 7 states, but it will be updated, I think, in this near time to the all the states. So these are different features like water. You can see different schemes of government that they are maintaining it. Similarly, there are different features. Special applications are there. Data discovery, decision support dashboard are there. So multiple features can be integrated for the decision making purpose. Okay. So these are the things that are there in Bhuvan. So we just see some few tabs like Bhuvan 2D. So Bhuvan 2D, you can see India's map here. Okay. In this, you can see there are two maps, base maps and base hydrology map. Okay, so base map basically basically that has been prepared by the Survey of India. Okay, so they have taken this image from the Survey of India. Basically, the administrative boundaries are generally created by the Survey of India. Okay, and then these maps, Survey of India maps, has been digitized. Okay, over here. And these satellite images that they are managed by the ISRO, you can say, the Bhuvan. So these are the images you can see here. This is the base hydrology. You can see the river basins over here. What are the river basins? Narmada basin, Ganga basin. So all the river basin you can see here. And this is a hybrid image. You can see it's all the administrative boundaries along with the river basin here. Terrain information is also there. So These are mountains which are here. So basically a slope map has been overlaid in this India's map, so you can find it out. So this is about the 2D and 3D. You can say it's just elevation thing has been added. So it is 3D model. So we'll check here for the 3D as well. Just a minute. Just note it out. 3D, you can see it's just looking like a globe. So it is in 3 dimension. Okay. Now moving to this open data archive. So in this, you can download the images from satellite. Different satellites categories are there. You can download the SCAT-SAT, OceanSat, ResourceSat 1, 2. List 3 images are there. So you can see here that the entire map is divided into the grids, and you can just zoom in to the places. Okay, so what you can do, you can just if you want some images, so just zoom it out. Okay, either you can give your if you know the latitude and longitude of your area, you can just give it and it will select those pixels. If you don't know your boundary box, or you can say boundary conditions on the you can use the map sheet also, and take the map sheets and geodifference topo sheet, and it will automatically select those grids. Similarly, you can select the tiles here also. So when you select the tile, there is a start option. So if you click the start option, and you can select any number of grids. So you have to press the shift button if you have to download multiple grids. Okay, so you can just keep selecting the grids by pressing the shift button. So this is how I have selected the grids. Okay, and you can just click the next button here and you will get the data. Okay, so these grids basically belongs to these topo sheet numbers. You can see here their boundary box is also there, information is there, and you can see there are different data paths are there. So which date you want to take, you can select from this. Suppose you want 2015 image, you can select here. Okay, this is the metadata information is also there. Metadata means what are the satellite information, which is the satellite is there. Okay, what are the coordinates are there. So these are the information about the satellite that is there for your reference. Similarly, you can see the thumbnail is just to view the images. So you can see that the image is good. So you can download. Okay, image you can verify the different images also. If this, you can see that there is clouds in the images. So this is not good. So you have to check whether the cloud is there or not. If there is less cloud, then it is okay. But if the cloud is a more, then you have to avoid those images. Okay. So any image you have to select, you can just select it and download. Okay. So it is also asking for the login. So you can do the login from home, but here. Okay. So you can do the login. Just register. Just give your name, email address, and things, and you have to verify your email. So once you do that, you can download any images of any part of the India. Okay. So this is about one. Now we are this is the portal that we have discussed. Now comes to the Earth Explorer. This is the you can say this is the most common site or most popular site, widely used site to download an image. Okay, so basically Landsat images are there that has since 1972. So the first images that is there in 40 years old. So currently the Landsat 8 images are there, but Landsat 9 is to be planned in this year to be used. So this is free to use. These are the pros. There's a largest library we can say in any platform that is available here. So you can download the digital elevation model. Digital elevation model is you can say it's a topographic terrain models. Terrain models means you can get elevation also. So the elevation feature is there. So I mean digital elevation model, or we can say DAM in a short word. So DAM is basically used for the topographic analysis. You can estimate the slope. You can estimate the drainage pattern of any area. So that's why the dam is very useful to get the elevations of any point. Okay, so this is about the pros and cons. Is limited access. Sentinel products are very limited, so we have to go for the ESA Sentinel hubs or Copernicus side that we have already discussed. So these are the things. I'm just going to show you how you can download the Earth Explorer data. So how you can download, which data to be downloaded, which data not to be downloaded. So here there are some points that has to be remembered. Like when we select any image, we have to select the maximum green area. So we will not opt for any date that is after the post harvest, we can say. So when the crop is completely grown out, okay, so when we take this image, we will get a very good results in analysis. So crop shouldn't be harvested, like I already said. It will be true representation of land. Okay, so there should be a very less work on pixel accuracy. And cloud, no cloud, it is very better. For cloud, less than 10%. Okay, so this is basically the images. That are the thing that are the precautions basically we have to take when we are getting to download the images. Okay, so there is one issue in with the Landsat 7 image where there is a scan line error after the 31st May of 2003. So that we have to see that Landsat image post, you can say 31st May has some issues. So first we go to that Earth Explorer and then see what exactly they are in. So just typing here USGS Earth Explorer. Okay. So you can see this image, right? Are you able to see this image? आपको ये स्क्रीन दिख रहा है? Hello?
Yes.
Okay. It's visible. Okay. So here we can see there is an enter search criteria there. Okay. So you have to see address and places and just mention any address. Let's say Jabalpur. And you can say show. So it's now giving the latitude and longitude of Jabalpur, Madhya Pradesh. Okay. So just click here. So now it's getting highlight this area. Okay. So here there are things we can get the data set from here only. Just get hit this data set and we get the data set. Okay, but here some filters are there, so you can just check those filters. So you don't have to do some extra, you can say, efforts to see the clouds. This is the filter. cloud cover is there. Additional criteria, just a minute. So here, so in this particular area, these are the number of imaginaries that are available in the Earth Explorer. You can see the aerial images. Okay, classified digital elevation model is there. So we are just looking for the Sentinel images are there, but Sentinel images are quite limited in this platform. We are specifically looking for the Landsat. So this is the Landsat platform, and you can hit any of this tab here, and you can get the image. Suppose you have select the Landsat 8, okay, and I'm just selecting this additional criteria. Okay, in additional criteria, you can specify your filters, like what are the cloud cover and cloud cover कितना होना चाहिए, क्या होना चाहिए, तो वो इसका एक options रहते हैं. So you can select those options. Where is the 10%? Let's identify is there. Then cloud cover 5 to 10% of impersonation here. And you can search it. So these are the images. Okay. So you can see these thumbnails footprint, that whether the image has covered the Jabalpur or not. Okay. So this is covering the image. You can also preview the images. So you can see that this is the image of November 2020. Okay. Similarly, you can get different images if you select this. This is a different period, March 2020. Similarly, this is the January image. Okay. So different period of images are there. Okay. And you can just submit the. Actually, I have just created multiple images. That's why subscription is asking. Okay. So, so we have selected this image. This is covering the Jabalpur part. Okay. So there is option for download. Okay. You just have to click this download option. This is the bundle that has been provided by the software. Okay. There is something little bit changed. These are the different band informations are there. Band 1, band 2, band 3, band 4, band 5, band 6, band 7. So these are the number of bands, and you can completely download this bundle. This is 932.74 MB. Okay. So this is how you can download the things. There are something, if you have to go for, let's say, just search the data set here. You want to download a digital elevation model, you have to go here. Okay. And you can select SRTM. So you can get the results. So you can also get the digital elevation model over here. So there are different data sets that are available in this particular site. So based on your criteria, what exactly you need, you can get the data. Number of things are there. Digital elevation model, SRTM, basically you can say a platform that is providing the digital elevation models. Similarly, you can see the old images are also there. You can hit this Landsat collection 1. You can see the old images are there. Landsat 1. Okay. So you can see here that these are the images that are available here. This is the cloudy image. You can see this is July 24th image. It's completely cloudy. If you see this March image, there are some little bit clouds are there. Now moving to the 2nd of March image, you can see this image is clear. So this image is clear. You can download this image. Okay, you just have to click here and you can get it. Okay, so which image you have to download? Which has a maximum, you can say maximum bytes. This is the largest image, TIFF image, GeoTIFF image that you have to download for your analysis purpose. So don't get confused because there are a number of options are there. So you just have to look for the TIFF image, GeoTIFF, which has a highest storage, 995 MB. So this is your particular image. And this image has multiple bands inside it. So you have to unzip it. So this is about the Landsat and Earth Explorer, how you can download the data. Now let's move ahead. You can see the introduction to GIS. Okay, so GIS, you all know that's a geographical information system. So geographical means geography is the word which basically studies for the feature, resources, climate, population, Earth features. Okay, Earth physical features. So basically we study what and where is this any object. Similarly, information is about the data, what the data that we are looking for. And system is to set of things that are being connected, okay, by the computers, or you can say the smart mobile also. Similarly, GIS you can define precisely as art and science, engineering, and technology associated with the spatial patterns and process and their management. So yeah, another definition is also there. GIS is a multidisciplinary and they represent a convergence of remote sensing. So these are the disciplines basically. You can remote sensing, surveying, cartography, statistics, operational research, computer science, mathematics, and the application areas. So this is about the GIS. So it's basically you can say the integrate the different fields in a one system. Here there you can see image data versus information. So there is a random data lying over spatially, okay, and this data random data when processed, basically when we extract those data and we get an information, okay. So from this random data we have get the information, and when this information has been processed we get the derived information. We can say we have represented them graphically, okay. So this is just an example to how the GIS works. So their data is there, data is scattered, we have extracted those data, we have got some information, and then we have processed those information to derive the graphical representation of particular geography. Similarly, GIS basically having the multi-layer data. So you can see here that you can overlay multiple layers like hydrography, elevations, infrastructure, soil, land use, registration of all the map layers on a common coordinate. So these layers basically belongs to the common coordinate. So they will overlay one to another. Okay. So on the basis of that, we can extract the information depending on the different features that are overlaying. Okay. So this is the overlaying of images. These are the components. You can see that the hardware is hardware, software, dataware, humanwares, and the process methods that forms the GIS. So these are the elements that are basically belongs to the geographical information system. First one is the data collection. So we have to collect some field data also for verification of our images. Satellite data is there. Field data, which we sample data that we have collected is known as ground truth also. So satellite data is there, aerial photos are there, analog maps are there, reports are there. So analog maps have been digitized and then used for the further processing. Similarly, data storage, there is an inventory. We have to create a geodatabase, we can say in GIS terms. So that is the inventory of database. So all the data are lying on geodatabase. Data manipulations. So we can reclassify the images. We can change the scales. We can registers, rectifications. We can do the enhancement also. Okay, so these are the things. So you can smooth the images also. So these are the things that you will be going to do in the practical classes started from the Monday. So now comes to the data analysis part. This is we can do modelings, statistical analysis, overlaying analysis, buffer analysis, and all. And finally, the outcome is in the form of images, graphs, maps, tables, and ASCII files. So this is the elements of GIS-based analysis. Now comes to why the GIS is so special. It's special because it basically facilitates the faster process of operations. It provides a solution for many real-world problems. It is a decision-making tool because we are adding multiple layers. We are let's take an example, like if suppose we have taken a slope, we have taken the water inventory, we have taken different aspects like lithology, geology, and all, and something on the basis of those informations, we have assigned the weights. Okay, so on the weightage, we are basically, why we are assigning the weightage, we have to make a decision that which site is appropriate for what. Okay, so this decision making is possible. Integrating technology, dynamic maps, displays, interactive queries. So these are the things which can be happen in GIS. So the primary focus is what is this? What is this means? क्या है मतलब आपका कौन सा location है? कौन सा object है basically? So identification of object is there. What is this means? Identification of object. Where is this? Means we are looking for the location. What is the change? So we are basically looking for the change detections. What if? What if means we are looking for the conditionals. Suppose we have taken some scenarios. If the temperature has been raised by 1%, what will be the impact on the other parameters? So what if we have put some certain conditions? So once we do this integrated analysis, and last one is the optimization and CPM. So we can reduce the cost through optimization. So this is basically the things that makes the GIS special. Now comes to the some basic terms in GIS. So scale. Scale is just a ratio of distance on a map to the equivalent distance on the ground. तो GIS का जो maps है, maps generally scale में ही बनते हैं. So you know what this word. So coordinate system is important because it's a reference system where we just represent the locations of geographical features, imaginaries, and observations. Okay, such as GPS locations within a common geographic landmarks. So there are two basically coordinate systems: geographic coordinate system and projected coordinate system. So what is map projection? Map projection, we can say, is because Earth is basically in a 3D phase, 3D surface, right? So in the map, we have to convert 3D to the 2D. So geographical coordinate has to be changed to the projected coordinate for creation of maps. So there should be some distortion, a little level degree of distortion is there, because we have to change the 3D image to the 2D image for the measurements, because measurements are only possible in the 2D image when we can do some measurements. Okay, so there's some distortion there in the image, but it's you can say it's not very significant, but there is some distortions. So resolutions we have already discussed, the smallest features which can be recognized in image, and in raster data it is a pixel size. We can say that's a 30-meter resolution, means that's the pixel size of 30 meter in 30 meter. That's the resolution. Now these are the GIS data models. Basically, data models to represent the real world in GIS. So vector models are basically you can say the points, line, and polygon. Point means if we mention any points in a map, we are assigning a location, latitude and longitude. Similarly, line is just an, we can say, the ordered set of this XY arrangement. And polygon is an area that is enclosed in a different coordinates. So here in the map, you can see here the points you can assign, like there are wells are there, land gauges are there, river gauges are there, villages, town. So if we have to reflect those things, we can reflect them in points. Similarly, line is like rail lines are there, rivers, roads, boundary of any area. So boundary, you can say, should be in a linear way. So we can define in a line. Polygon is something that we have to define the basins. We have to define the land use, forest, soil. So these are the polygons. Similarly, the raster data model, the image basically consists of the array of cells, grids that we have yesterday discussed. So each grid has some digital numbers. Digital numbers, basically what it does, it shows the variance. Okay, so a point, we can say it's a single pixel in a raster model. A line is a chain of, you can say, connected cells. So, and polygon kya hoga? Polygon is, you can say, the water body in a raster data, the set of contiguous pixels having same value that represent a homogeneous area. Okay, pixels में अगर आपका एक ही area है, suppose करिए water body को दिखा रहे हैं, so that should have a same digital number to represent as a homogeneous value. Okay. So there are the softwares, GIS softwares like ArcGIS, ADAS, NB, MapSat, ADAS, Small World, Autodesk, GNT, Surface, Dropworks. These are the paid softwares basically. And the open source GAS, Quantum GIS, Elvis, Map Windows, these are the open softwares. So I've just highlighted the Quantum GIS because this training will be going in this QGIS only. So we are going to do practicals in QGIS using QGIS. So this is about QGIS and how remote sensing and GIS together can be used. This has been covered by Dr. Shivam Krishnan sir. So I just mentioned this, like meteorology, there's weather forecast, climate studies, and global changes, hydrology, water balance, energy balance, agrohydrology, soil science, land evolutions, and land soil mapping can be done. Biology, vegetation mappings, vegetation condition assessment we can do. Forestry, deforestation, forest inventory, forest fire detections that can be done. Environmental studies, soil pollutions, water quality, climate change can be done. Agriculture engineering, land use development, erosion assessment, water management planning can be done. Physical planning scenario studies can be done. And land surveying, topography, this DTM means digital terrain models, and spatial data models can be used in land surveying. Similarly, in agriculture, you can say the crop water requirement prediction we can do, crop agriculture and yield estimation, crop condition assessments, soil moisture evaluations, and suitability mappings can be done through remote sensing and GIS. That is all from this session. If you have any questions, you can ask me.
Hello.
Yes, sir.
I'm Dr. Lalit Bal. I am a food engineer. So I want to know how can I use this GIS and remote sensing in my research.
Sir,
I did
what
not
is the
find
objective?
anything. nahi. I'm a food engineer working on food engineering
Food
thing.
engineering, you can just make an inventory, like you can
Sorry,
even.
it's not clear.
Uh,
Hello.
yes, sir. आवाज आ रही है?
Little bit louder.
आवाज आ रही है सर?
हाँ, जी.
सर इसमें फूड इंजीनियरिंग में आप एक तो ये आपका वेयर हाउस मैनेजमेंट का देख सकते हैं कि जो आपका बेसिकली सप्लाई चेन मैनेजमेंट जो है फूड प्रोसेसिंग इंडस्ट्रीज में जो है, तो सप्लाई चेन मैनेजमेंट हो गया, वेयर हाउस इन्वेंट्री हो गया आपका क्रॉप का, कि अगर आपको कोई सर्टेन एरिया है, जैसे सपोज करिए कोई कमर्शियल क्रॉप्स लगी हुई हैं, and you have made an inventory that this particular area is growing this commercial crops. So industrialization can be done. So what are the proposed sites for the industrialization you can do? So these are the things that you can do, sir, in food engineering.
Okay. ठीक है. Thank you.
Yes, sir. So I think there are no more questions. So thank you very much, sir, for attending this session. So we shall meet around 3 p.m. today for the next session from Dr. N.R. Patel, who is going to discuss about abiotic and biotic stresses in agricultural crops. So thank you very much, sir.